All right, number 16. The diagram shows graph at f at x, local max, vertical asymptote, y-intercept. Let g equal the reciprocal function. Write down the coordinates of the y-intercept. So we have y-intercept at 0, 3/2. We need y-intercept at 0, 1 over 3/2, which is 2/3. Local min, which is the same x as the local max of the original function, and we need 1 over 2. So that's the min. On the same diagram, sketch that. Okay, so vertical asymptotes become roots. Let me do in red. And roots become vertical asymptotes. And at -2. And we have 0, 2/3. So about there. And 3/2, 1/2, which is a bit there. So this is the min. Okay, so it needs to now have, just we have to be careful about when it's positive and negative. So it needs to be negative here. So we're going to have something like this. And then it's positive. So we're going to have something like that. And then it's negative up until 4. And then positive after. And you can get some points like, you know, this is like, I don't know, 5, 2. So we're going to have 5, 1 over 2. You can get, you know, 9, 1. So it's going to be 9, 1 over 1. So it's going to be something like that. Okay, 17. Here's the graph of f at x in between -2 and 2. Write down the range of the following functions. So we're going to be in between 0 and 4. For the y's. For y equals f at x squared. So anything on the line, horizontal line 1 stays. So these points stay. So anything that is above y equals 1 is going to square, okay? So this one here is going to become 4 up here. This 4 is going to become at 16. All right, this 2 becomes 4. So it's going to be like up there. You know, this is going to be up at 16. Okay, so it comes back down. At 0, it comes back down to 0 because anything between 1 and 0 is going to be, so like this one, I don't know, at 1/2 here, this is going to become 1/4. So it goes like this. And then 0's there. And same, yeah, it goes back up like this. And then same thing on this side. This is going to go up to 16 and come back down to 0. So this is going to be in between 0 and 16. So for the square root of f at x, we're just taking the square root of the y's. Okay? X's stay the same. So if we have 0, it's going to stay on 0. If we take the square root of 4, it's going to become 2. So everything in between square root of 1 is going to stay the same. You know, it's going to look like that. Okay? So our range is going to be in between 0 and 2. Sketch on the axes provided the graph of y squared equals f of x for negative 2 to 2. So that's just y is the square root of f of x. And I've already got the top part of it because, yeah, I guess it's plus or minus. So we're going to have here, here, here. And at 2, 4, it's going to become 2, 2. Not 2, 1/2, 1.5. So here and here. And then we'll stay on the ones. So that's like here and here. Okay, and then, 1 would be square root of 3, all right? But that's that. Maybe a little smoother, but whatever. And then we just flip that over because it's going to be the plus and the minus. So we're going to be down here. We're going to be here, back up at 0. We're going to be here, here. So it's going to be like a little bow tie. For 18, the diagram shows the graph of y1 and y2. On the diagram, sketch the graph of y1 over y2. Indicate clearly where the x-intercepts and asymptotes occur. So if you think about this, y1 over y2, whenever y2 is 0, we're going to have an asymptote. So that's here and here. And whenever y1 is 0, it's going to stay 0 because we'll have 0 over whatever is 0. So here is going to stay at 0. When they're both positive, like here, so this until here, they're both positive, it's going to stay positive. And when one's positive and one's negative up until, nope, not there, here. So it's going to be above the x-axis here. It's going to be below the x-axis here because one's positive, one's negative. Here, they're both negative, so it's going to be positive here. And then it's going to be negative here. So it looks like in between here, it's going to be like this, approaching the vertical asymptotes. And then it's going to be negative on this side. Don't know. Something like that. And it's going to be positive over here. So something, I guess we shouldn't go beyond. So maybe like that. Okay. So, yeah. Now, on the following diagram, sketch the graph of y1 minus y2. Indicate clearly where any x-intercepts. So we want x-intercepts. So that's when y is 0. So it's when y1 equals y2. So when they intercept, that's going to be an x-intercept. So here and here. So if we want to know when y1 minus y2 is less than 0, less than the x-axis, that's just when y1 is less than y2. So y1, which is the solid line, is less than y2 here before that x-intercept. So we're here. And y1 is less than y2 here. Here's y2. So we have, it's below the x-axis here. And you can see that the difference is smaller, here. The difference is smaller and it's just getting bigger and bigger and bigger. So you're just going to go like that because it's just going to get a larger and larger difference. And then when is y1 minus y2 above the x-axis? Well, that's when y1 is greater than y2, and that's happening there. So something like that. It may be a bit smoother, but all right. Last one, 19. Consider the graph of the function f. And the equation f at x has one solution at x equals 4. Find the other solution. So we can use the graphing calculator. So when you change your window from about negative 2.5 to 5, and I've got the y min at about negative 150 and y max 150. And when you find the minimum, so analyze graph minimum, you get 3 negative, whoops, so positive 3, negative 131. And then the range, so we need the lowest it goes on that interval from negative 2 to 4.5 is negative 131. And you need to find out how high up it goes for negative 2 and 4.5. So you should do menu 5.1, menu trace, graph trace, and type in negative 2, and you get 144. And for 4.5, you get 208.188. So basically your graph is looking like, so if we're between negative 2, so that's at 144. Up here, 144. And then it comes down, and then it goes down like this, and then it goes back up. So at 4.5, it's at 208, whatever. So, excuse me. So your lowest is at negative 131, and your highest is going to be 208. And then we'll just do not included here, because we've rounded it. All right. A sketch of the graph of 1 over f is given below. Write down the two equations for the vertical asymptotes. So remember, the roots are going to be the vertical asymptotes. So for C, we're going to have x equals 1.43 and x equals 4.5. Those are the vertical asymptotes, not 4.5, 4. C, the graph has a max at P. Write down the x coordinate of P. Okay, so it's just going to be the same 3, and because it's a min here at 3, negative 131, it's going to be a max at 3, 1 over negative 131. I know they just asked for the x coordinate, but whatever.